Alright, Computer Graphics Introduction, Human-Centered CAD Learning, March 24th, 2009. This was in Sequel National University, Open Courseware, Computer-Aided Design, and we're on Lesson 4, Computer Graphics. Computer Graphics Introduction, Human-Centered CAD Lab, March 24th, 2009. Basic theories in computer graphics. Computer graphics is essentially a tool of computer-aided drafting. Interactive shape manipulation is essentially the element of computer-aided drafting. Graphic library. You have to have a driver or hardware-dependent software to drive specific graphic device. Different graphic devices are driven by different driver routines. Application program, driver, input-output devices, cathode ray tube. Basically, how you permit a picture, we have a heating filament, cathode grid, a control grid, a focusing system, vertical direction, horizontal direction, interior metallic coating, high positive voltage, electron beam, phosphorus coating. And that's basically cathode ray tube. And then it picks up, this is kind of how your television works, it picks up red, green, and blues. And these red, green, and blues are shot through the mask, and they are beamed in conveyances in the phosphorus glass faceplate. Display process. You have a computer that gives graphics demand to the digital process and display process to give the data back to the computer. The frame buffer works with the display processor with the cathode ray tube, which comes up on your screen. There are liquid crystal displays, or LCDs. Each pixel of the liquid crystal display typically consists of a layer of the molecules aligned between the two transparent electrodes, two polarizing filters. Axes of transmission which are perpendicular to each other with no actual liquid crystal between the polarizing filters. The list of passing through the first filter would be blocked by a second polarizer. Molecular orientation of liquid crystals is twisted according into the electric field polarization of incident light and rotated through liquid crystal layer. LCD crystals shows a color filter, horizontal filter, a crystal molecule, glass plates, vertical filters, and we've seen it now going to spots into lines. Graphic library, continued graphic library collection subprograms performing graphic functions by calling driver routines. Each subprogram implemented drivers routines. Application program, the graphic library, the driver to input-output devices. Graphic library continued. Any graphic library can support limited drivers. Application program written specific graphic library may have to be written when a graphic device is not supported by a used graphic library. Better to have some sub-programming names usage in all graphics libraries. Core Graphic continued. Core Graph system in the 1977 SIG-Graph special interest group of the computer graphics under the Association of Computer Machinery, and these were weak and raster graphics. The graphic kernel system, or GKS, standard 2D graphics, and graphic kernel system 3D. Alright, we have PHIG, or PIGS, Programmer's Hierarchical Interactive Graphic System by an ISO supported with dynamic display, better use and interaction. PHIGS, extension to X, extension of Program Hierarchical Interactive Graphic System by using window capability of X. You have graphic library, open graphic library, coordinated system, reference coordinated systems to specify location points on the object, the projected location on the screen. Device coordination system, horizontal axis screen between the U-axis and the vertical axis between the V-axis. U and V, integral value, number of pixels, define location on the screen. Different graphical devices have different original location ranges of U-axis and vertical and become the V-axis, U and V values. Virtual devices coordinated system. Origin is located in the same location with respect to on the screen. Respective UV values are the same. Location screen is provided with the device driver in the virtual coordinate. The driver changes with the coordinate with the specific device coordinates. Reference coordinated system describe the whole scene used to describe the location orientate. World coordinated system, or reference coordinated system to describe the whole scene. Used to describe location orientation of objects in the scene. Used to specify the location of the viewpoint and view site. Model coordinated system fixed to each object. Model coordinates of the points on the object do not vary with model translated when it rotates. Object translation rotation is described by the location origin axis orientation of model coordinated system. Viewing coordinated system used to facilitate projection calculation of 3D points, determine the viewpoint and view site, and we have viewpoint and view system. So we've now looked at the world coordinated system, the web view site, the viewpoint from the eye to the view site and the screen, which would give you a flat state on the view site, and you can change view site. Viewing coordinate system, we have X view, Y view, Z view coordinate, originate website, ZV is the view site of the viewpoint, YV is the vertical upper direction screen, XV is the points of right screen of the view from the viewpoint, open graphics library, originate viewpoint, viewpoint, view site to viewpoint, viewpoint to view site, left hand coordinate system. Two types of operations. We have a perspective projection and parallel projection, viewpoint center point projection, YV, and USENT. So we've basically changed the size. And then we have parallel projection, where the view site pretty much stays the same size. That's when you're scrolling in between your view sites. Parallel projection points object represented in X, Y, and Z, V locations, coordinates, and used for X and Y and Z screen coordinates. Project projection, side view, view site, top view, screen, viewpoint, and perspective projections continue similar rule. You determine screen coordinates X, Y, and Z, V coordinates. The X, V, S, X, S, and then the Y is obtained with a projection of the project vector on the screen by screening the up vector camera location is fixed. Transformation between coordinate systems. Alright, we have coordinate value of the model coordinates. The model transformation goes into coordinate values in the whole world coordinates. The view transformation goes into coordinate view coordinates. And then the projection transformation, virtual devices coordinated into device coordinated. Viewing volume to specify the volume of the display. Similar to the window, we look outside of the inside of the house. Viewing a volume of the parallel projection, horizontal vertical size of the X and Y vertexes, so X and Y view coordinates. So we have view site, view volume, viewpoint, window, screen, viewing volume, perspective projection, view volume, center point, viewpoint, window, screen, view site, view volume, near plane, far plane, usually either too far, near the viewpoint, far plane, near plane, screen, viewing volume, window, viewport. Graphic on graphic region graphic monitor, where the screen is projected to viewport mapping. Display monitor, viewport 1, viewport 2. Viewports continued. Viewports are specified by using virtual device coordinates, location on screen, location on viewport, scaling and translation. Same aspect ratio is desired. And this was Computer Graphics Introduction, Human-Centered CAD Lab, March 24th, 2009. And this was Computer Design, SNU Open Coursework, National SCL, National Universe Computer Aided Design, Lecture 4. Next, we have Matrix Transformation.